Okay, let's take a look at skill 2. The second thing that you're going to be expected to know from this particular section. Okay, skill 1 was you have to be able to plot given points on the polar plane. Skill 2 is give other representations of a specific location. So it's not that I'm going to plot a point, though we could plot a point and I could say give me 3, 4, 5 different representations of that particular point. I'm going to actually give you an ordered pair. All right, so polar coordinates here. -3, 135 is our first one. Now, the book has formulas for figuring these out, and it's more, I think, an intuitive idea than just memorizing formulas and plugging these in. I like to plot the point out and then figure out the other 3, because if you take a look, I say give 3 other representations of the following points where your theta is between -360 and 360. So let's get the polar plane up. First thing I do is I actually plot the point and then figure out the 3 points from that location. So -3, 135. So 1, 2, there's -3. Circle of radius 3. 3 units, 3 spaces to the left of the pole. And then 135 in the counterclockwise fashion. Again, you gotta be careful. I mess this up sometimes myself. This is clockwise, this is counterclockwise. So we're actually going 135 degrees, which pulls us 45 degrees shy of a half turn. So follow this around. That would be 45 degrees shy of a half turn. This is the point that they're naming. So -3, 135 is one representation for this point. We can even write it, -3, 135. But as we saw in the last video, that's not the only representation. We can name this point in infinitely many different ways, except the directions kind of restrict our thetas. It has to be between -360 and +360 inclusively. So what I'm going to say is for these particular problems, I look at my r and I look at my theta. If you notice, I gave you an r that was less than 0. It was negative. I gave you a theta that was greater than 0. It was positive. So we're going to hit every other combination of this, meaning a negative r and a positive theta. Well, what are the other combinations? Well, there's a positive r, leave space for a number there, and a positive theta, my favorite one, the easiest one, positive r, positive theta. That's one I have to give. I'd have to do a positive r and a negative theta. That's a different combination. And finally, well, a negative r and a negative theta. That's basically what I'm going to give. And like I said, leave some spaces for some numbers here. Now, the r's are spoken for. You're going with 3 or -3. So I already put the plus sign. That's going to be a +3. That's going to be a +3. That's going to be a -3. So what I'm going to do is I'm going to say, okay, I'm going to go 3 spaces, since that's positive, to the right of the pole. So 1, 2, 3 to the right of the pole. And then I have to go a positive angle, meaning I have to go 3 spaces, and I got to go counterclockwise to get to that point. So what would that be? Well, counterclockwise to get to that point pulls me 45 degrees shy of a full revolution or a full turn here. So 45 degrees shy of a full turn would be a positive 315 degrees. Sloppy. All right, second one. I've already determined I'm going to go +3 again. And then I have to meet up with this point, but I've already determined that I'm going to go clockwise to meet up with that point along the circle. Well, clockwise is a short move of 45, or I should say -45. And then finally, what if I go -3, just like the original point was? The original r was -3, but instead of going counterclockwise, 135, I go clockwise. Well, that would be 180 and 45 more, puts me at -225. And that's how you can name 3 points and stay within your restrictions, -360 to 360. Right? not really that terrible, but you've got to know how to do this. All right, now that second one I put up there, it's not just another run-of-the-mill. I mean, I suppose you could consider it a run-of-the-mill, but I picked an angle that's not particularly pleasant in 157 degrees. So what we're going to do is approximate, and we have to be real sure about our math here and where we're located. All right, so first let's plot what 4, 157 would be located at. So 4, 157. 3, 4, 157. Well, there's 120, 135, there's 150, there's 165, 157. Would that be something like that? Almost halfway between. 7.5 would be exactly halfway. Half of 15 is 7.5. So yeah, we're going to say right about there is the point for 157. Now, immediately what I do is I say, okay, how far away from this left polar axis am I? Well, if you think about it, 157 degrees to 180 is looking at 23 degrees. 23 degrees shy. So that's 23 degrees shy that way. And we already have the 157 counted, but that 23 is a helpful marker. And I'm not saying positive or negative, I'm just saying 23 degrees away from that polar axis that goes to the left. All right, so to name these, let's see what we got. We got a positive r, and we got a positive theta, unfortunately. So that's the easiest one. So what do we need? We need a positive r, and we need a negative theta. We need a negative r, and a positive theta, and we also need a negative r, and a negative theta. That should be the other three that are missing. Right. Now, it doesn't have to be in any particular order, just make sure you have all three combinations there. Right. So, 4, 157, well, this says positive, and again, my r is pretty much spoken for. Is it going to be 4, or it's going to be negative 4? That really doesn't have much leeway there. The thetas, though, that's going to determine it. So, positive 4, so 1, 2, 3, 4, but this time don't go 157 in the clockwise fashion, or the counterclockwise fashion. We have to go, I don't know, we have to go all the way around back up to here in the clockwise fashion because it is negative. Now, that's why I put that 23 in there as the marker, because I know that's a half turn at 180, and 180 plus 23 puts me at 10, 1, 203. So 4, negative 203. Okay, well, let's try negative 4. Kind of get rid of this. So what if our r is negative 4, and I have to go counterclockwise? 1, 2, 3, 4. Now I have to go counterclockwise. Counterclockwise would be this way, because I'm calling it positive. So I have to go basically pull up 23 degrees shy of a full revolution. So 23 degrees shy of 360 puts me at 360 minus 23. Old school here. We're looking at 733. 337 if my math holds up there. Okay, and then also negative 4 the short way. Going clockwise, that's just simply negative 23 degrees. And that's basically how it's done. So my suggestion is don't memorize formulas. They're in the book if you want to go that way, or you have some other system, fine, it works as long as it works. But what I'm saying is I think the most straightforward way, not necessarily the fastest way, but the most straightforward way, most intuitive way is to just plot the point and then figure out how you would count that out using your positive and negatives for r, positive and negatives for theta. Right?